Hello and welcome to today's mathematics learning lecture. So like always, we're going to start with our key knowledge autumn test. So you should have this on the sheet in front of you. So I'm going to give you 4 minutes to have a go at that. Off you go. Okay, brilliant. So I'm going to put these answers up in just a second. But I want to go through a couple of questions first. I'm not going to go through all of them. I am going to put the answers up, but there's a couple that I want to talk through. And the first one, now, truncated is the word I wanted to think about. This word truncated. Now, truncated just means to cut off. So if I had something like, let's say, 4.1592, and I wanted to truncate this to one decimal place, it means that I'm just going to literally, doesn't matter, I don't round at all, I just cut everything off after the first decimal place. So I'd literally just cut it off. So the answer to that one would be 4.1. So with this one here, this has been truncated to 1 decimal place. So the lower bound of this can be anything down to 54.2. And the upper bound of this, because it's not rounded, can be everything up to 54.3. And that's because it's been truncated and not rounded. Okay. The other one that I just want to quickly talk about is the pyramid one. Just to remind you of the formula for a pyramid. So the formula for a pyramid is a third times by the base times by the perpendicular height. I'm just going to put h for now. So you've first of all got to work out what the area of that base is. In this case, it's going to be 3 times 4 because it's a rectangle. 3 times 4 is equal to 12 centimeters squared because it's area. So it's going to be a third times by 12 times by the vertical height, which is 4. Brilliant. I might as well just quickly have a look at this one. Compound interest, only because it comes up so regularly. Because it's an add, because it's an increase, I'm just going to tell you what the starting point is. So it's 100% plus 3.75%, which is 103.75%, which as a multiplier is going to be 1.0375. And then because it's over 16 years, I'm going to need to do that to the power of 16. Brilliant. So I'm going to put these answers up. So mark those in green for me. Mark those in green. I'll give you a second just to do that. Okay, I'd probably just put on the side what you got. Maybe if you got 7 out of 8, then put 7 out of 8. Hopefully you got 8 out of 8. Now remember that all of these questions I'm going to do on a repeat. So when we do our next learning lecture in 2 weeks, they're going to be the same questions. So make sure you're trying to understand them. Okay, so moving on. So today we're going to be looking at 2 things: cumulative frequency and histograms. Okay, cumulative frequency and histograms. Now, just going to move myself down a little bit there. So, cumulative frequency. Now, you've got this on your sheet. So, we're going to write down what the definitions are. Cumulative frequency is the running total. Okay? So, a cumulative frequency diagram is like... a cumulative frequency diagram is a line that goes up. It's a line that goes up, and it looks a little bit like a stretched out S, okay? It looks a little bit like, it should look like this. Maybe I should say curved line there. It's a curved line that goes up, and it looks a little bit like a stretched out S. So a visual way to display continuous data using a visual way to display continuous data using a histogram bars can be unequal in width. Now, the thing that's really important with this is this part here where it says frequency density, because the frequency density is what it goes up by, okay? It's the y-axis. So frequency density is equal to your frequency divided by your class width, okay? So a visual way to display continuous data using a histogram. Bars can be unequal in width. And this is the key part here. The frequency density is equal to your frequency divided by your class width. And a histogram shows the frequency density here on the y-axis. Now that's really important. We'll come back to that in a little second. Now the reason I'm doing both of these at the same time is because they look very similar. If you look both at the start of these, they look so similar, but they're completely different. One, it looks a little bit like a bar chart, like this. You might have seen it before. Remember, this is a recap, okay? One looks like this, and another one looks like this, okay? Now, the cumulative frequency is the running total. Now, the key to this is it's always from the upper bound, but I'll leave that for now, okay? But the first thing I need to do is to work out what my running total is. So I'm going to do this one as an example. I am going to give you a chance to have a go at some of these yourself. So the cumulative frequency, the first one is 3. Then it's going to be 3 plus 10, which is 13. Okay, then it's going to be 13 plus 21, which is equal to 34. Then it's going to be 34 plus 4, which is equal to 38. And then it's going to be 38 plus 1, which is equal to 39. Okay, so 3 plus 10, 3 plus 10, plus the 21, plus 4, plus 1. Brilliant, 39. This here is your cumulative frequency, and that's the starting point for that. This one here is your frequency density, which is different. And this is the part we need to think about this. Frequency density is equal to your frequency divided by your class width. Now, your class width is the width of that. So the first width is 20. The second width between 20 and 30 is 10. This width here is 10, okay? It's your frequency divided by your class width. So your first one is going to be 10 divided by your class width, which is 20. So 10 divided by 20, which is equal to 0.5. The next one's going to be 35 divided by 10, because that's your class width there, which is equal to 3.5. The next one's going to be 65 divided by 10, because the width between 30 and 40 is 10. So divided by 10, which is equal to 6.5. And the last one is going to be 40 divided by the class width of this one between 40 and 80 is 40. So it's 40 divided by 40, which is equal to 1. Okay. So that's our starting point. Now, I am going to do more. Let's just check those. Brilliant. 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 So, sorry, I didn't realize you couldn't see that. So there's all the answers to those ones. That's fine. Just checked all of those. Okay, so let's have a go at 2 questions now, okay? So let's have a go at these 2 here. Now, this one here says draw a histogram for this data. Now, you will need a ruler for this, okay? So take your ruler out. So remember, a histogram is equal to, now up here, you'll notice on the side, it's the frequency density, all right? The frequency density is on the side. And to find out your frequency density, it's equal to your frequency divided by your class width. So your frequency density, so in this first one's going to be 15 divided by 30, because the class width there is 30. The next one's 22 divided by 10. The next one's 28 divided by 10 again. The next one's 30 divided by 50, 60, 70 divided by 20 that time. And the next one is 9 divided by 30. Brilliant. So let's work all those out just very quickly. So 15 divided by 30 is equal to 0.5. Make sure you're getting these down on your sheet. 22 divided by 10 is equal to 2.5. 28 divided by 10 is equal to 2.8. 30 divided by 20 is equal to 1.5. And 9 divided by 30 is equal to 0.3. Now what we do is when we're doing a histogram, remember this is a histogram, okay? With a histogram, we need to plot these like bars, okay? So the first one is between 0 and 30 up to 1.5. So let's do a line across there. I'm not going to be able to use a ruler on this. There's my first one there. The next one, I need to do between 30 and 40 up 2.2. So let's do that one there. Up to 2.2, which is there. And it's between 30 and 40. Yes, brilliant. You make sure you're using a ruler. The next one is between 40 and 50, up 2.8. So 2.8 is going to be there, and that's between 40 and 50. There we go. The next one is between 50 and 70, and that one there is 1.5. So 1.5 there, like so. And the last one is between 70 and 100, and it's 0.3. So I need to go up 0.3 and across. You make sure you use a ruler, make sure your line's nice and straight. I can't do that on this. Maybe I should have tried it with a ruler, okay? So that is there is a histogram. And remember, a histogram is your frequency density is equal to your frequency divided by your class width. Okay, you should have done this already. Okay, so next up, we're going to be looking at our cumulative frequency now. Now, remember, cumulative frequency means the running total. Okay, so my running total for this, the first one is 12. The next one is going to be 12 plus 30. So 12 plus 30 is equal to 42. The next one's going to be 42 plus 28, which is equal to 70. The next one's going to be 70 plus 22. 70 plus 22 is equal to 92. And the last one, 92 plus 8, is 100. There we go. Now, remember I said to you at the start of this that we need to do it from the upper bound, okay? That's the difference here. Remember, it's a smooth curved line like this, but you always do it from the upper bound. And the reason that you do it from the upper bound is because you're doing everything up until that point. That's what the running total is. Between 20 and 30, there are 12 people in this. Between 20 and 40, there are 42. Between 20 and 50, there are 70 people. Okay, so let's plot these now. So the first one, now take note here, my starting point is 20, so I need to be at 20, 0. The next one is 30, 12, so 30 and then up 12, which is going to be there. The next one is 40, 42. 40, 42 is there. The next one is 50, 70, so 50 up to 70, which is there. The next one is 60 up to 92, which is there. And the last one is between 70 and 100, so 70 and 100, which is there. Now be careful, you do not start at 0, 0. You start at where your lowest age is. In this case, it's 20. And remember I said it looks like it should be a smooth curve. It looks a little bit like an S. That one's a little bit like a stretched out S. Well, there we go. Okay, so you've got two things there. You've got your histogram, which is like your bars, and you've got to work out the frequency density. And then you've got your cumulative frequency, which is that smooth curve, the S. Okay, so have a go at some of those questions yourself now. So have a go at those questions yourself. I'll give you 4 minutes to have a go at those. Off you go. If you turn the sheet over, you should find one cumulative frequency and one histogram. Okay, brilliant. So let's pop the answers up. So take your green pens out. Let's have a look at these then. So looking at this first one here. So this one here was asking for a histogram. So your frequency densities were 0.24, 0.42, 0.34, 0.16, and 0.06. Then we have to draw these out using our ruler. Okay. Next one here, cumulative frequency. Remember, the cumulative frequency is the running total here. Okay. So our running total here, in fact, it already gave you the running total here, so we didn't need to add these. Okay, because it was already between 0 and 20. So you're literally just plotting these because it already gives you the running total here. So we're literally just plotting it for 2 marks. Again, notice it's from 0 and 20, 0 to 40, 0 to 60. And you're always using the upper bound here. Last one here was another histogram question. Again, we're working to work out the frequency density. Frequency density is equal to your frequency divided by your class width. Okay? So 36 divided by 4. 40 divided by 2. Now, the reason I've picked these questions, just to let you know, is because they come up every single time, okay? So make sure you understand it. Make sure you know the difference between cumulative frequency and histograms. Have a lovely day, and I hope you enjoyed the video.